despite this being completely a review question from previous years, there are some struggles with this question. Okay? Ask yourself what you would do first. Okay? And I ask you to do that because from my experience in the past, I think I've gone over this question quite quickly, and I realize that people have forgotten some stuff from grade 11, and they don't know what to do first. And if you don't know what to do first when this comes up on your test, that's like the worst case scenario on any math question. I forget what to do first. Because if you forget what to do first, does it matter if you remember the rest of it? No. You can't even get started and then lose all of your marks, which is disastrous. Okay? We have a lot of like terms. Put like terms together. That's always helpful. So for example, I can move the 5, and I mean, you're in grade 12 now. You don't have to show this, but sometimes it's kind of fun still to go back to grade 9 and do that kind of stuff. Right? I can move my numbers to one side, and I can subtract 2 sine x on both sides. So if I move my 5 over here, I'm going to get a 2 on the left-hand side. If I subtract the 2 sine x to the right, I get a 2 sine x on that side. So first of all, if we have like terms, put them together. Then, every time we've solved for a trig equation, we want to get the trig equation by itself. But right now, there's a 2 in front. Well, I can divide both sides by 2, and I can get my trig equation by itself. So now, things are good, okay? And I'm going to model how a typical high school brain would go about this question. They'd be like, okay, I combine my like terms, sine x equals 1. It's a non-calculator question, so I go to my memory, I go to my pi plate, and say, is my y coordinate ever equal to 1? Yes, right at the top, right? Y coordinates equal to 1 right at the top. Now, depending on where your brain is at, maybe your brain remembered this question was in degrees, and you wrote 90 degrees. Some students will write pi over 2 here, because they won't remember what if you're in radians or degrees. Okay? But despite remembering that I was in degrees, we get into a habit of always, and this is not a bad habit, we get into a habit of always solving our first positive time around the circle. So in degrees, we get into a habit of solving between 0 and 360 degrees. In radians, we get into a habit of solving between 0 and 2 pi. And that is not a bad habit as long as you check what they want you to solve. And if we look at this one, right, Theo's shaking his head. He's like, oh, what did they ask us? I've solved between 0 and 360. And they want us to solve between negative 360 and 0. So that's once around in the negative direction. I know my answer is here at the top. If I'm going in the negative direction, what would be coterminal with 90? Negative 270. So just going to lightly put a line through that. And write negative 207. And then I reread the question, and it says, then write the general solution. So again, rereading the question is important because you might miss that they ask you to do even more. I personally, as a student, liked it when they want me to do more. Why not make it A, B, and C? Then I won't miss it, right? But if they ask me 5 things all in one question, I'm bound to miss something. But unfortunately, the textbook likes to ask lots of questions all together. The exam does it sometimes. Always good to reread the question at the end. So the general solution. Well, if we go back to our notes from yesterday, the general solution had two ideas. It said, first solve between 0 and 2 pi. But this question's in degrees, so we translate first solve between 0 and 360 degrees. And then all of your answers add to k pi. So for me personally, I would be like, hey, I did right here with the green arrow that I stroked out with the red pen. I solved between 0 and 360. There was only one solution. So for my general solution, x will equal 90 degrees, and then I would add 360 degrees times k, where k is an integer. The textbook on this very same question, if you go to the back because they have solutions to this, you'll notice they write this. So is the black one wrong? Is the blue one better? What are we doing when we're writing the general solution? The general solution, and this is why this is good, because you have to know how to write coterminal angles in chapter 6. Coterminal angles say, pick one of them, and if you add 360 times k, you will get to every single one after that. Because 360 times k, k could be positive or negative, so you could either add or subtract and get them all. 90 degrees says start at the top and then list them all. The second one in blue says negative 270 is like, oh, start at the top and then list them all. So these are exactly the same. It's just how we describe the first one that we're starting with. And personally, I like to do the first positive one. But you'll find your textbook will sometimes, if you've made a new domain, then they make a new domain. Yes.
On a test, would we have to put both of them on
No, just one. Just showing you that there's more than one way to write the right answer. You can pick any coterminal angle, right? You want to make my life miserable, you could write 3,690 degrees. And I would have to check, is that actually up here? Because if it is, then it's right. I shouldn't give you guys hints for making my life miserable. You're like, revenge. Mr. Chair, you are already making my life miserable with all this math. I'll get you back. All right. Part B. Part B to this question, use algebra to determine the general solution of cos 3x equals -1. Okay? All right. And if we read this question, they want a general solution. Okay? They also want the roots between -2 pi and 0. So what I'm going to do is I'm going to start with the general solution. And in the side, right, this is just in my head because the general solution had 2 steps. Solve like normal between 0 and 2 pi, and then we're going to add 2k pi. That's in my head for general solution. So if I want to do the general solution, this is what I need to do. So then I go to my question and I'm like, oh, but I have a 3x inside. that 3x inside should remind me, hey, this is a multi-revolution question. So now we have multiple things happening at the same time. This is what makes grade 12 difficult, because you have to remember a whole bunch of different things even if they come together. So how did we solve our multi-revolution questions? Well, first we rewrote the domain. And if we're solving between 0 and 2 pi for x, so we want to get x between 0 and 2 pi, then 3 x's. If I triple everything, the domain for 3x will be between 0 and 6 pi. Second, we're going to solve for 3x. Is -1 on your pi plate? Yes. Cos is your x coordinate. -1 is over here at pi. So the first time around the circle, it's going to be pi. How many times do we have to go around the circle for 3x? 3 times, because we have to go to 6 pi. Second time around the circle, we would have 3 pi. And the third time around the circle, we would have 5 pi. To get x by itself, divide each of them by 3. And for almost every type of domain that you get given to you, no matter where it is always helpful to have a reference of the answers the first time around. Now we know the first time around there are 3 answers. 1 at pi over 3, 1 at pi, and 1 at 5 pi over 3. We're going to be able to answer all questions if we have this basis. Okay? So what did this question actually want? It wanted a general solution. So if I have between 0 and 2 pi, between 0 and 2 pi, then my general solution is easy. I just write all of the answers that I found between 0 and 2 pi. And I write every single thing that's coterminal with them. There's my general solution. Again, now if we reread the question also said x, right? Oh, did they include 0 and 2 pi? They didn't include 0? All right, I really like my little eraser. Sometimes I make mistakes on purpose just to be able to use it. Why was it helpful? Now, I know where my answers are between 0 and 2 pi. One of them was pi over 3. Right? My first one was pi over 3. If I went in the negative direction, can you see that that's coterminal with -5 pi over 3? My second answer was pi. If I go in the negative direction, this one's really easy. We can see that it's pi. And my third one was 5 pi over 3 in the negative direction. That will just be -pi over 3. So again, having our solutions between 0 and 2 pi helps us with our general solution, helps us with our solutions between -2 pi and pi. I believe the answer key for the general solution in the textbook, they might have used these ones, the negative ones here, instead of the positive ones. I personally like to use the ones between 0 and 2 pi. So you can circle 4, 8, and 9.